Hello everyone, and welcome to our video on self-referencing as SQL. In SQL, a relationship between a table and itself is called a self-referencing relationship or a self-join. To query data across this relationship, you must perform a self-join. This involves joining the table to itself by treating it as two temporary, separate tables, often given different aliases. Let's connect to a SQL Server. Now, let's go to our database in Object Explorer and select it. Then open a new query. We will create a new table in this database. This query will create a new table named Invoices, where customer invoices and their payment status will be stored. Let's execute this query to create the table. The table has been created, and we can refresh the tables to view it in Object Explorer. We can also use the select command to display it in Result window. This is the table, which does not have any data yet. So let's add data of a customer using query. This query will add data of a customer named Jack for previous 1 year. Let's use the select command to display the data after it has been added to the table. Let's execute this query. And here is our table, with all the invoices and their payment status. Let's add data of another customer. And now we have data of two customers named Sarah and Jack. Now, let's close this query and create a new view. Let's say we want to view the history of previous 3 invoice payments in the same row as current invoice. For that we will add the same table multiple times, each for one past history. Now, we will connect invoice dates of all tables to the invoice date of original table. And similarly, customer field of all duplicate tables, to the customer field of original table. Let's arrange these tables in a way we can see the relationships more clearly. You can see all those relationships in this select command as well. Now, let's select all fields from the original table, and only status field from all duplicate tables. You can see the changes in query window as well. Let's rename these fields to status 1, status 2 and status 3. We cannot simply call them status because each field must have a different name. That's why they were given temporary names when selected. We can also test this query before saving it as a view. We have now 3 more status fields, however they do not display previous status, instead they display same status multiple times, because same invoice date is used as relationship. To get the status of previous month, we will relate the previous month date of original table with the first duplicate table, using end of month function with -1. Similarly, we will use the end of month with -2 while connecting to second table. And finally, the end of month with -3 to connect to our third table, to get 3 months back status. Now, here month-end dates are being used, therefore we are using end of month function. If it were daily data, we would be using previous day dates by excluding 1 day from date, instead of 1 month. Now, let's save this view, and then use the select command to display the results. Refresh views to display the view. Let's display the data. Here is the table, and observe that it starts with 4th month, because first 3 months do not have previous months to display in history. And you can see that it displays historical status of previous 3 months, excluding the current month, accurately. This is one way. You can display data from same table in another row of the same table. And while viewing current invoice record, we can see the previous 3-month customer history as well. Let's close these queries and open a new query window for another example of self-referencing. Let's create another table name employees, with employee IDs, their name, and the IDs of their managers. Here is our table. Now, let's add some employees to our employees table. And let's use the select command to display the data in result windows as well. This query will create an employee table with the columns and add some employees' records into that table. Let's execute this query to create the table. Our table has been created. CEO has no manager, so there is no manager ID for him. And here are the rest of the employees. Now, in front of each employee, you have the ID of their manager, but imagine if you want to display the name of their manager against their ID as well. What will you do? There are more than one ways to do this, and one of those is self-referencing. Now, let's close this window. Create a view, and add the employees table into that view twice. It may have created a relationship based on employee ID automatically, but we don't want that, so delete that one. Instead, we will connect the manager ID from original table with employee ID from the duplicate table. Now, select all fields from the original table and employee name field from the duplicate table. And rename that field to manager name. Save the view now. Refresh the views, and you will see the new view. Now, display the data from this view. And here you go. Now you have all names of managers in addition to their IDs. CEO is missing, because they don't have a manager. However, we can modify the view, and change it to outer join, to display CEO as well. And now you have CEO as well. And that is because left outer join here means include all data from the original table. And these were some examples where we can use self-referencing. We will leave more use of self-referencing to your imagination. See you in our next tutorial. Till then, have fun learning SQL.